Welcome to the last lesson of Unit 3, and we are learning about solving systems of equations algebraically. So the essential question is, how can the substitution property assist in solving systems? Now you know all about the substitution property. When we use a subprop, we use parentheses always. So let's get down into a little bit of review before we really get into it. This first one right here is one solution. Now this is a system of equations, and so we're going to graph both. Now I'm not going to be highlighting like this or highlighting the slope like that. I'm just going to leave them blank, and I'm going to go ahead and start. So the very top one is the b is 1. So I go on the y-axis and I do my y-intercept, just like our last lesson. And then my slope next to the x is a 1, and that means my slope is 1 over 1. So I'm going to go up 1 to the right 1, up 1, right 1, and so on and so forth. Now what's also equal to 1 over 1? Negative 1 over negative 1. So I'm going to go down left all the way. And that would make a lot of sense because all of these points are lined up in a nice straight line. So graph your line, and then put arrows on the top and bottom. Now let's go for the second one. My b on my second one is negative 5, so I go all the way down to the bottom. And then my slope is negative 2 over 1. Well, negative 2 over 1 won't work with this graph because it's going to go down farther, and I don't have the graph to do it. So another way to say negative 2 over 1 is 2 over negative 1. So that means I'm going to go up 2 and left 1. Up 2, left 1. Up 2, left 1. I'll draw my line, put my arrows, and I can see that my solution is right here. And that solution is negative 2, negative 1. And that's graphing to find your solution. But that's not quite what we're learning today. We're learning how to find the solution algebraically. All right, and this is how it works. Notice up here that y, got a little red mark there, there we go. Y at the top is exactly equal to x plus 1. Notice on the bottom or right below that, that y is also exactly equal to negative 2x minus 5. Well, if you think about this, this y right here is the exact same thing as this y. So if those y's are the exact same number, and what number are they? They are negative 1, because we know that to be true. Then that means this value, x plus 1, is the exact same thing as negative 2x minus 5. That's just a rational thought. So let's take that rational thought down below here. We're going to write x plus 1 is exactly equal, what did we say? To the blue one, negative 2x minus 5. Now when you write that equation, you see that the y's are now gone. And now we're going to go back to Unit 2 that we learned all about how to solve for x. So before we begin, we're going to attack the subtraction sign down here and do additive inverse. And look what we're doing now. We're going to remove this negative 2x from the right side by adding a positive 2x. That's the inverse operations. And then we're going to do the property of equality to the other side. Now since we're moving our x terms to the left, we are then going to move our constants to the right. To remove adding 1, we're going to add a negative 1 to both sides. And if you remember, and I know you do, 1 plus negative 1 is 0, and negative 2x plus 2x is also 0. So then we do our math on both sides. X plus 2x is 3x's, and negative 5 plus negative 1 is negative 6. Then we divide both sides by 3, and you can see that x is officially negative 2. Now where have you seen that before? Up in the graphing. What was x? X is negative 2. Well, once you have your x, all you have to do is pick either the top equation or the bottom equation and solve for y. Oops, let's fix that. All right, don't have a lot of room left, so off the margin I'm going to go. The top equation looks a lot easier to deal with than the bottom one, so I'm going to write y, whoops, y is equal to x plus 1. Now, why did I put parentheses? Because I'm substituting in a negative 2 into the parentheses. So I'll put a negative 2 in there. And negative 2 plus 1 is negative 1. So when x is negative 2, y is negative 1. And that probably also looks familiar to you right up here. And now we can find both our x and our y coordinates without a graph. Let's try the no solution one. Remember, x or y is exactly equal to this, and it's exactly equal to this. But I'm getting ahead of myself. Let's graph these two first. The first one is y-intercept of 3 and a slope of 3 over 1, and also negative 3 over negative 1. My next line is y-intercept of negative 2 and the same slope, 3 over 1, up 3 over 1. And you can see that these two lines are running parallel to each other, and we already knew that before we even started because the slopes are identical. Well, they absolutely have no solution. So in the Google form, you would write down no solution. No spaces, all lowercase. Now, how did we get that algebraically? Well, we know that if y is equal to y, then that means this green expression is exactly equal to this blue expression. So let's write those expressions down below. 3x plus 3 is equal to 3x minus 2. Now we need to get our x terms together, so we're going to add a negative 3x to this side. If we do it to one side, we'll do the property of equality and do it to the other side. And since we're moving our x terms to the left, we're going to move our y terms, our constants to the right by adding a negative 3 to both sides. Now we look for our zeros. We know this is a 0. We know this is a 0. But we found one additional 0, this one. And that means our x terms are gone. And so what's on the left side of the equal sign? 0 is equal to negative 5. Is that true? It is not true, and that tells you that it is a no solution. There is no coordinate that's going to make it true. So we go down to this next one, and we graph the top number. It's ready to go. So our crossing point is negative 5, and our slope is negative 2 over 1, which that's going down. We want to go up. So 2 over negative 1 is going to give us a nice alternative. Draw your line. There it is. Now this next one we have a problem with because we have a negative sign in the front of it. So I'm going to write this one. I'm going to smash it right here. Sorry about the pen problem. Soon to be fixed. All right, we have a nice little negative sign in front of the y. We don't want that, so we're going to divide both sides by a negative, and that's going to give us y is equal to negative 2x plus negative 5. Now we can graph that. Negative 5 is our y-intercept, and we have the exact same slope, so we're going to go up 2 over 1, and you can see that this line is going to be right on top of our last line, and that means the answer is infinite. Right, infinite solutions. All right, so algebraically, what would this look like? Well, we're going to do this one a little bit differently because you can see up here the y's are not the same. We can deal with it. So what we're going to deal with is we're going to take this bottom one right here and we're going to rewrite it, but watch how I do this. We're going to do y parentheses, a big long parentheses, is equal to 2x plus 5. Now where did I get this one from? I got it from up above. It's this equals 2x plus 5. And I added a parentheses where the y was. Now, up here, it says y is exactly equal to negative 2x minus 5. And if negative 2x minus 5 is exactly equal to y, I can substitute this green piece into here. Negative 2x minus 5. That is the green part up above. Now, what's in front of this parentheses that you can't see? A little 1. And I'll also have a subtraction sign right in the center there. So I'm going to use additive inverse on that. And now I'm going to distribute this times this and this times this. Well, negative times a negative is a positive 2x, and a negative times a negative is also a positive 5. And this side equals 2x plus 5. And you can see automatically that both sides are identical. And if we keep on going by adding negative 2x's to both sides to try to join the x's together, and then we add negative 5's to both sides to try to join the constants together, you can see that we have zeros all the way across. And that means 0 is equal to 0. And because that's a true statement, we know that's an infinite solution. All right, now that we learned all about one, none, and infinite, let's go ahead and get down in here and start using algebra to solve these. Now this one is really easy. We are shopping for a coordinate that they cross. And we already know one of the answers. One of the answers is y is what? 2. So we know y is 2. It's already telling us the answer. But we don't know what x is. So we're going to label 2 as our substitutor, and we are going to use this equation to substitute with. So that's y is equal to x plus 8. What goes inside there? The substitute, which is 2. Now x is on the right side, so we need to remove the plus 8 by adding a negative 8 to both sides. Now we have our 0, and x is negative 6. So now we know that it's negative 6, and that is our solution. Well, how do we know that we are perfectly correct on that one, that the two lines cross at that moment? Well, you can just put these answers, your x value and your y value, back into this equation. You can see that they are true. And you can put your y term back into this equation, and 2 is equal to 2, and that's true as well. So they satisfy both equations. Let's try it again. This one has a value of y being negative 4x minus 1, and the bottom has a value of y being exactly equal to negative 2x plus 3. Now we can see here that this y is equal to y, so that means that this has got to be exactly equal to that. Now let's search for our answer. We know there will be an answer because if you look closer, right here, our slopes are different. So let's start. Negative 4x minus 1 is equal to negative 2x plus 3. We need to join our x's together. You know that I'm going to choose the smaller of the x's. I'm going to add a 4x to this side and a 4x to this side. So since I'm moving my x terms to the right, I need to move my constants to the left by adding a -3 to both sides. Now it might be a little bit confusing up here because I had a subtraction sign. So I'm going to do additive inverse just to help my brain out. And I can see that I have a 0 here and a 0 here. So it looks like it's going to work. So -1 plus -3 is -4. And -2x plus 4x is 2x. Then I divide by 2 on both sides, and x is -2. Well, we found it. X is -2. So now we need to search for our y. And this is where you have to decide which equation, the top or the bottom, is the easiest to work with. Now I'm going to choose this one simply because it has only one negative sign and a plus sign. I think I feel like that's better than having a subtraction sign. So I'll use that one. And I'll do y is equal to -2 parentheses for the x plus 3. What goes in there? My -2. And -2 times -2 is +4, and 4 plus 3 is 7. So I think that is the right answer. But to make sure, all I have to do is put my -2 in right there and my 7 in right here. And it should work. I know it works on the bottom one, but on the top one, let's check. What is -4 times -2? It's +8, and +8 minus 1 is indeed 7. So I know that is the crossing point of the system. Let's try another. On this one, I would like you to pause the video and try it on your own. Pause the video now. Welcome back. Now I got 1 for x, and hopefully you did too. If you didn't, then go back and see where you went wrong. Now I came back on the video here to explain that I need to make a choice. Do I use the top one or the bottom one? The bottom one looks like a whole lot easier to deal with. So I'm going to write y is equal to parentheses for the x plus 2. And my x is 1, so I'll put a 1 in here. And 1 plus 2 is 3. So I believe my solution for my system is 1, 3. Now I'm going to put that into my top one just to see if it's right. That's my x, and this is my y. 2 times 1 is 2. 2 plus 1 is indeed 3, and I know it's right. Now, I'd like you to see number 4 and go, that looks familiar. That was in our last lesson, and I remember Mr. Croker saying, hey, it's too hard to tell what the solution is on a graph. It was unknown. That is the exact same problem that we did. So what you're going to do is make this equal to this, just like we have been doing. So set that up. 2/3 x minus 2 is exactly equal to -1/3 x plus 2. We know that there is a solution because the slopes are different. So let's start working on this. Let's remove the -1/3 x by adding a +1/3 x to both sides. And since we're moving our x terms to the left, we're going to move our constants to the right. And that says -2, and the inverse of subtracting 2 would be adding 2. Now I don't usually do that. Usually I do the additive inverse up here just so you can see what I'm doing, but I'm starting to not do that as much for my advanced students. So I'm going to add 2 to this side as well. You can see here that I have a 0 here and a 0 here. And these are nice fractions because the denominators match, and 2/3 plus 1/3 is actually 3/3. Well, 3/3 is exactly 1, and 1 times x is x by itself. And on the right side, you can see that 2 plus 2 is 4. So we know what our x value is. Our x value is 4. But now let's search for our y value. Now you have to determine which one's easiest to deal with. So I'm going to go ahead. I don't really know which one's easiest to deal with. I have a -2 up here, but I have a negative sign down here. So I'm going to choose this one. Sometimes it's just not so clear. And I'm going to go to the margin and work on that. So here we go. Y is equal to 2/3 parentheses for the x minus 2. And remember, we found x to be 4. So we're going to put a 4 in here, and we're going to turn that into a fraction. Now we're going to multiply first here. 2 times 4 is 8, and 3 times 1 is 3, and it's 8/3 minus 2. Disregard this. This is from before. Then I'm going to do a little bit of additive inverse, and I'm not really, those aren't compatible to add together, so I need to change my -2 into something I can use. So I'll keep my 8/3, and I need something over here with a denominator of 3. Well, 3 times -2 is -6. And that will work perfectly because -6 divided by 3 is -2. Well, now I can add these two together. 8 plus -6 is 2, and the thirds will remain thirds. All right, pen ran out of ink, had to charge. So then this is 2/3. All right, so y is what? 2/3. No wonder we couldn't see it on the graph. Now let me take you quickly back to the lesson 9-6 when we experienced this problem in the notes. Right here. Look where it crossed. If you look very closely, it crossed right, whoops, let's fix that. It crossed right here. And that is 4 over on the x, 1, 2, 3, 4. And look at that. If I split these up into thirds, that is pretty much 2/3 right there. So that's why it's hard to tell, but algebra helps us to figure out the answer. So that is the crossing point, the solution. This was another hard one because we didn't know if it was an infinite or no solution. Well, we now know that it doesn't have the same b, so you pretty much can tell yourself that it is a no solution because the slopes are the same, but the b's are different. Let's go ahead and do it. We'll make this equal to this. -2 and 5/10 translated, if you go ahead and take the time from our last lesson, is -5 halves x plus 0 is equal to -5 halves x plus 1/2. You know, I want to fix this. I want to take away this plus 0 because the original one didn't have plus 0. So we'll leave it like that. Now we have x terms on the left and the right, and so we need to move them together. I'm going to remove this -5 halves x by adding a positive 5 halves x. If I do it to one side, I'll do it to the other. And you can see what happens here. On this side, it's gone, and this side, it's gone. And so that means that 0 is equal to 1/2. And we all know that that is not true. So this is a no solution problem. This next one, you might say it's a no solution as well. But wait. We have y is equal to x exactly. And y is also equal to -x. So let's set those equal to each other. X is equal to Sorry about that. I had to take a little mental break when I was teaching. All right. So we have our x and we have is equal to negative x. And you might be saying right away, there's no way that's possible. Well, let's start working on it. I'm going to remove this negative x from this side by adding a positive x. If I do it to one side, I do it to the other side. And you can see that I do create a 0 over here, but on the left side, I actually create two x's. And those two x's are exactly equal to 0. Well, now I need to divide by 2 on both sides. And you can see that x is exactly equal to 0. All right, that's interesting. Now I need to find out my y. So I can choose the top or the bottom. And I can tell you right away that the top one is super simple to use. Y is equal to whatever x is. Well, what's x? 0. And so you might be thinking, even watching this video, you're like, well, how would it work here? But watch. Y is equal to negative x. Well, what's x? 0. And what's a negative x? What's negative times 0? 0 as well. 0 has no positive or no negative. It is just 0. So either way it works. That's an interesting one. And our crossing point is at the origin. All right. Now here's a couple more intense ones before we get into our homework. Watch this one. I want you to notice before you even start working on it that you have an x all by itself right here. So what you're going to do is you're going to create a nice substitutor. And so I want you to take this into the margin and go x minus 4y is equal to negative 8. To get that x all by itself, we need to remove the minus 4y. Well, you could add an additive inverse to it to make it a little bit simpler. And we're going to add a positive 4y to both sides. That's going to give us x is equal to 4y plus negative 8. Now that's not slope-intercept form because you have an x out in front, but it gives you a great substitutor for x. All right, so now we have a great substitutor. X is exactly 4y plus negative 8. We're going to use that. Oops, let's fix this up here. We're going to use that to help solve. We're going to use this problem right here. So let's go ahead and write that down. But instead of writing an x, we're going to write a nice big parentheses. And you can see that 3 is there, and the rest of the problem is there, but we replace the x with a parentheses because we're going to use substitution. And in this spot, we're going to put the value of x. Well, we know what the value of x is now. We know it is 4y plus negative 8. So now we're going to simplify the left side. So we're going to use the distributive property and get 12y's plus negative 24 minus 12y is equal to negative 6. Now we would love to add these terms together, but the problem is we have a subtraction sign, so we're going to use the additive inverse. And now you can see that we put the 12y together with the negative 12y. Well, the y's have disappeared. And what's left over? Negative 24 is exactly equal to negative 6. And that is not true. So this problem has stopped, and you know it is a what? No solution. All lowercase letters, no spaces. That's as far as you got to go. Let's try number 8. What would be a great variable to use? Well, you can see this y right here is all by itself. So let's see if you can hang with this. I'm not sure that you can. You need to replace the 3x, and to do that, you need to add a negative 3x to both sides. And when you do that, you're going to get y is equal to, there you go, negative 3x plus negative 14. And now we have a great substitutor for y. And since I used the top one for my substitutor, I'm going to use my bottom one to work it out. So on my bottom one, I'm going to rewrite 9x plus 3 parentheses, nice big parentheses for the y, is equal to negative 42. And remember, this one is my blue one. And I left my y open to substitute in, my y, which is negative 3x plus negative 14. So I'll distribute now and get negative 9x plus negative 42 is equal to negative 42, and then I'll bring down this 9x plus. And you can see what's going to happen right here. 9x plus negative 9x is 0, and what's left over? Negative 42 is equal to negative 42. That's a true statement, so this is a infinite solutions, all lowercase. And I'd like you to pause the video. This one's a really nice one for you because we already know what y is, and so y is a great substitutor. Pause the video and try it now. All right, it's been a long lesson, but the answer to number 9 is negative 3, negative 2. Pause the video and take a look at all this math if you didn't get the same, and make sure that you are using it correctly. When you're ready, you come on down to the assignment. Put your first name, last name, date, and period. Always do that first. And take a look at these. They are way easier than what was in the notes. So, we are simply just going to do this. Y is this? Y is that? So let's make them equal each other. We'll do a little bit of additive inverse. It's not necessary for all of you. Plus 2 on both sides. And you can see that x is 6. So that's a part of your solution. Well, what's y? It already tells you. It's 4. So you're done. When you put it into the Google form, make sure you use your parentheses, 6 comma 4 in parentheses with no spaces. We're going to do all of the odds together. So I'll start here. I already know my y value is 6. So I'm just going to substitute this piece right there. And that 6 is equal to x minus 5. I'll add 5 to both sides. And I can see that x is 11. I already know a part of my answer, y is 3. Now I need to know my x. So I'll use this top one. I'll substitute in 3 for the y. And I will add 9 to both sides and get x is 12. Sorry about the pen strokes. Soon to be fixed. All right. This one, a little bit more complicated, but not too bad. Y is this and y is this, so I'll just set them equal to each other. And I'm going to remove the x from this side by subtracting an x from both sides. And you can see that negative 5 is equal to 1x. Now that might throw you a little bit, but remember there's little 1's right here. And remember that we have an additive inverse right here. So it is x is negative 5. Now we need to search for a y. Well, this bottom one's super easy to use. Negative 5 times 2 is negative 10. Number 9 is very similar. Oops, I am going about it all wrong though. Try it again. I need to move this x term by subtracting x. There we go. Then divide by 2 and x is negative 4. All right, so I need to put this into this one right here. 3 times negative 4 is negative 12. Remember, you can always check these. You can put your x right here. And negative 4 minus 8 is actually negative 12. So you know you're getting them right. Number 11. I'm not sure that we did this one in our notes. It looks very familiar to me. And that's 2x minus 1 is equal to x plus 1. I'm going to remove this x. And I'm going to send this, since I'm bringing my x's to the left, I'm going to move my constants to the right. Instead of subtracting 1, I'm going to add 1. And I can see my zeros popping up here and here. And that's going to be x is equal to 2. All right, I'm going to put this 2 right there, and 2 plus 1 is 3. Number 13, this one's a little bit more work, but I see that I have a single x right here, so what I'm going to do is I'm going to remove this minus 4, whoops, not like that. Remove it by adding 4y to both sides, and that's going to give me x is equal to positive 4y, because I sent it to the other side, plus negative 1. Now what I didn't show is the inverse operations and property of equality. You can do that yourself off to the side over here, and you'll find out that it is x is equal to 4y plus negative 1. Now that's a great substituter, so I'm going to use this top one to substitute it in. So 2 parentheses for the x plus 2y is equal to 3. And I'll put this in there for substituting. I'll do my distributive property. I'll put my y terms together, and I'll get 10 y's. And then I will remove the 2 by adding 2 to both sides. And I'll get 10y is equal to 5. And I'll divide by 10 on both sides. And y is, 5 over 10 is a half. So I found my y, it's a fraction. I'm not scared. I'll pick one of the problems, and I'll put a half in there somewhere. So I have to decide which one's going to be easier to put the half in. I think this one. So I'll rewrite that problem. Kind of took a lot of room away. So that one is x minus 4 parentheses for the y equals negative 1. And I put a half in there. And I'll do some additive inverse. And negative 4 times a half is negative 2. I'll remove the negative 2 by adding 2 to both sides. And x is 1. And the last one, I'm going to pause the video and just do it off screen, then you'll see it again. And here we're back. You can see number 15. The answer is 5, 15. And I usually choose either the top or the bottom to check my work. But in this case, I saw the one that I created as x. I'm like, that's going to be easier. So I put 15 back in here. 2 times 15 is 30. And 30 plus negative 25 is 5. Now you can put this answer here and here, and you will get negative 25. I already checked it. I know it works. If you need any extra help on this, you could rewatch portions or even come and see your teacher.